now let's estimate the square root of 18, 21 and 24. The procedure we follow is the same as what we did before. So let's start off by first drawing the number line. Let's say I'll start here and up there. So the line goes from here, say up to there. Now we write down the numbers starting from 16 ending up with the perfect square 25. So let's start off. So this should be 16 and the side length will be 4 and the end should be 25. And why do we choose 16 and 25? Because they are the two perfect squares between which 18, 21 and 24 lies. So let's subdivide this interval just like we did before. Let's use 3 squares to represent one length. So 16, so this will be 17, 18, 19, 20, 21, 22, 23, 24, 25. So let's number them. So this will be 17, 18, 19, 20, 21, 22, 23, 24, 25. And what's the square root of 25? 25 is a perfect square, and therefore this is just 5. We don't need this extra line segment, we get rid of it. Just to be neat. Okay, so now we have to subdivide this just like the way we subdivided before. So I will use blue color. Now let's see where the middle of 4 and 5 is. Graphically you can see it's probably here. Now we have to make sure that this is in fact the middle of the 4 and 5. And how do we check? We can check by just counting the number of squares between these two. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and a half. So you have 13 and a half squares between the 4 and 5. And let's see on this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and a half. So you have 13 and a half squares on this side as well. So yes, we are right. This blue point is in fact the middle of 4 and 5. So let's erase these values which were helpful in locating the middle of 4 and 5. Okay, now just as what we did before, what you want to do is you want to place 4 points between 4.5 and 4. You want to place 4 points so that they are equally spaced. So let's do that. So this is done actually graphically. Let's say this is 1, 2, 3, 4. Likewise, so you have 4 points and 5 segments, and each segment is of equal length. So let's do the same for this part. So that will be, let's say here 1, 2 3 4 5. Now this segment looks little longer than say this one, so this was not a good division, so I'm going to erase it and redo that part again just to make sure that I get it right. So let's do it again. So I'll put it here, 1 2 3 4 5. This looks better, but better, much better. So we have these segments here. Okay, now let's put the values. So this will be 4.1, 4.2, 4.3, 4.4. This will be 4.6, 4.7, 4.8, 4.9. Looks good. Now it's easy to recognize where the square root of 18, 21 and 24 falls. Like before, this is the side length of a square, and up here is the area. So let's see where 18 is. 18 is right here, and you can see 18 is closer to 4.2 than 4.3, so that we can say that square root of 18 is approximately equal to 4.2, which is an estimate. Likewise, where is 21? 21 is right here, and you can see it's closer to 4.6 than 4.5, so it's right here. So you can say square root of 21 is equal to 4.6, which is again an estimate. Then 24, we can see 24 is right here, and 24 is closer to 4.9 than 4.8, so that you can say square root of 24 is equal to say 4.9, which is an estimate.